Question 2 from the midterm. We are given, it's a complex numbers question, and we've given two different complex numbers. We've got 3 minus 4i, and we've got 1 plus 2i. And it asks us to plot them on the Argand diagram. Now, an Argand diagram is just this coordinate grid. Effectively, you've got your real numbers on the x-axis, and you've got your imaginary numbers on your y-axis. So when you have a complex number, which is a combination of both, you've got a real part and an imaginary part, you're effectively going to plot, in this instance, 3 minus 4. And 3 minus 4 is at this point here. Whilst 1 plus 2i is 1 and then positive 2i. And it asks us to, from the diagram, is it possible to say whether the modulus of Z1 is greater than the modulus of Z2. So what they're saying is the length or size of Z1, i.e. the distance it is from the origin, is that distance greater than the distance that Z2 is from the origin, the size of Z2. So if you just visualize what we're talking about here, we're talking about that length for Z2 compared to this length for Z1. Now, just looking at it, you can see that the modulus of Z1 is definitely greater than Z2. So is it possible? Yes, it is. Okay, so that's to answer the question, and we're asked to give a reason for answer. Well, because Z1 is further away from the origin than Z2. We might describe it in terms of length. So if we call this length A and this length B, we can say that A is greater than B in length, possibly. You might show using a set of compasses, you might show the sort of length of Z2 coming down to the number line compared to Z1. You might show it that way. We can clearly see that Z1 is further away from the origin than Z2 is. And as long as you're able to articulate that point, that's all that's required. You're then asked to do that same basic process, I suppose, not graphically, but algebraically. Now what they mean algebraically, they mean numerically. You're going to use the formula for a modulus. So in this instance, what we're talking about is when you have a complex number of the form a plus bi, then the modulus of z is going to be the square root of a squared plus b squared. Now that's basically Pythagoras. All we're saying is if you've got yourself a right angled triangle, then you're looking at working out the hypotenuse of that. So for Z1, which is, let's just remind us, it's 3 minus 4i. Well, the modulus of Z1 is going to be the square root of 3 squared plus minus 4 all squared. Make sure you deal with that minus 4 all squared properly. When you work it through, you get the answer 5. Compare that with the modulus of Z2, which is the square root of 1 squared plus 2 squared, which gives us the square root of 5, which is 2.2 something, but clearly 5 is greater than the square root of 5. And lastly, part D, it's basically asking us to do a multiplication. So we take Z1 and we're going to multiply it by Z2. This is just opening up the brackets, distributing each of the numbers in the first set of brackets over the second brackets. So what we're talking about is 3 multiplied by 1, 3 multiplied by 2i, minus 4i multiplied by 1, minus 4i multiplied by 2i. So what do we get with that? Well, 3 times 1 is 3, 3 times 2i is 6i, minus 4i times by 1 gives me minus 4i, and minus 4i times by positive 2i gives me minus 8i squared. Now if you remember right from the top of the page, it mentions that I squared is equal to minus 1. So we have a situation where when we tidy this up, we have 8 lots of minus 1, 8 lots of minus 1, or sorry, say minus 8 lots of minus 1 will give me a positive 8. So when I add that 8 onto the 3, I get the answer 11 plus 2i. And just to overtly state, what I've done with the 6i and the 4 and the minus 4i is I've just combined them, tidied them up straight away to get me the 2i. So that the I terms come together, and the number and the I squared term eventually come together to make 11.